Okay, so I wanted to show you EMF and potential drops. So as you can see, EMF is the total power supplied by a battery into the circuit. So EMF is this E. EMF is that E, the power source. So the power source, as you can see, current will be moving from here, from the power source, going that side. So this current, we can call it I. Fortunately, when this current reaches this point, it divides into two. One goes through that direction, going through that resistor R1, we can call that current I1. And then another one which divides goes through resistor R2, we can call it I2. So fortunately, when again these two join, I1 passes through R1, then comes to pass through R3, and joins up with I2, which passes through R2, and then they come up with still I, back to the source. Now the potential drops are when you get the resistance R1 times the current I1 at that point. So you have I1 R1. That's a potential drop at that point. Then even here at R3, you have current passing through there as I1, then times the resistance R3. Then this becomes a potential drop. Then also another potential drop would be I2 R2. So the sum of all of those potential drops, I1 R1, I1 R3, and I2 R2, should be equal to the EMF of the source, the sum of the EMF of the source. But we are going to dismantle, we are going to tackle that in detail and see how we bring in the loops such that they can help us to deal with, to come up with good solutions for such circuits. As you know, a loop is just kind of a ring which can be closed or not closed but drawn. So that would be a loop. So we are the next thing is we are going to see how to determine the direction of current and say that either for that case the EMF is positive or negative. The current is takes a positive direction, takes a positive sign or a negative sign. So that one is going to bring us to sign convention in Kirchoff's laws. Thank you very much.